electric lines of force. So electric lines of force, if you consider a charge over here, this is positive charge Q, and if you bring a test charge here, so test charge is always positive, and if this charge is free to move, then where it will move? Because this is positive and this is positive, so this will push it, so it will move somewhere here. From here again it will push, then it will move this way. So that means this charge, if it brought here, then it will move like this. If it is brought somewhere here, then it is to move this way. If it is placed over here, then it is going to move this way. If it is placed here, of course it is to move this way. If you place here, then this way, like this. So that means this is nothing but the charge was initially here, then it moved here, then moved here, and like this, until the field of the charge up to which it is being influenced. That means this electric line of force is nothing but the path followed by this unit positive charge if it is free to do so in the electric field. So it will be up to the electric field जहां तक इसका influence होगा. So electric line of force can be defined as the path followed by unit positive test charge in the electric field if it is free to do so. And now since the charge is positive here and it is moving away, so that's why the electric field as well as the electric lines of force are outward. So electric lines of force are outward if Q is positive. Electric lines of force will be inward if Q is negative. Just take the case negative charge, then what will happen? Just see. If it is negative charge, and if we put a charge, positive charge here, then it will pull it there, and then it will be here, then it again pull. So the charge is to move this way. If you put here, then it is going to come here. If it is here, then it is going. If you place it here, then it is going to come here. If you place here, then it is going to follow this path. If you want to place here, so it will follow this path. So this way, what we see, the charge, that unit positive charge, is moving from that point towards the negative charge. So that's why electric lines of force in that case are inward if charge Q is negative, that means less than 0. If it is more than 0, then it is outward. Uniform electric field. Uniform electric field means where the electric field lines are same in every region. That means they are parallel lines. So this is also uniform electric field. This is also a uniform electric field. So what is the difference between this E1 and this E2? So here the electric lines of force are having more space between them. Here the electric lines of force have less space between them. So you can just judge it. If it is a positive charge, electric lines of force like this. So just see, at this place, the intensity of the electric field is at A and at B. Here the electric field, suppose I take a unit area like this and the same area over here. So how many electric lines of force are passing through this space? Only 3. Whereas in this case, how many are there? 1, 2, 3, 4, 5. So here the electric field intensity is large. आपको पता है वैसे भी कि जब नजदीक होगा तो field intensity is more और जब दूर होगा तो electric field intensity is less. That means if the concentration of the electric lines of force in a particular area is large, then it is a stronger field, and if the concentration of the electric lines of force in that particular area with equal area is less, then the intensity will be less. So here same thing is, here the electric field is weaker as compared to this. So here E1 is less than E2. Both are uniform, but this is stronger, this is weaker. Properties of electric lines of force. Properties of electric lines of force. First property is if the charge is positive, then they will originate outward. If it is negative charge, then they are going to merge into the charge. Second is they will shoot always perpendicular to the surface of the charge. ये ऐसा नहीं है कि टैक्सी चली जाएगी ऐसे. No. It will always shoot perpendicular like this if it is positive, and if it is negative, then again it is to come perpendicular. It cannot come like this. No, this cannot be. It will always shoot normal. बाद में बेशक it can change its path due to the influence of other charges. That is separate issue. But they will always be normal to the surface. Third is they never intersect. These electric lines of force will never intersect. Why it will never intersect? Because the electric line of force is the curve tangent to which at any point gives the direction of electric field. So that means this is the tangent. If suppose we have here a charge, so electric field due to this charge will be this way, and suppose there is some other charge due to which electric field will be somewhere here. So the resultant in these two will be arranged somewhere here according to the magnitude and distances of these, and so will be the direction. So that is the tangent to the electric lines of force. Means if we have two lines intersecting, that means the force, the net resultant electric field will be this side, and according to this, the net electric field will be this way. At one point, the two directions of electric field cannot be. They will adjust somewhere at single direction. ये भी अभी देखिए दो थी ना, इधर भी थी और इधर भी थी. But ultimately, their resultant was at one direction, somewhere one. So here also, if you consider this electric line of force, then the direction has to be this way. If you consider this electric line of force, then the direction has to be this way, which is not possible. That means the electric lines of force will never intersect. Next, they exert lateral pressure अगर एक इलेक्ट्रिक लाइन ऑफ फोर्स यूं आ रही है और दूसरी यूं जा रही है तो इनको इंटरसेक्ट तो करना नहीं है. So what will happen? It will exert repulsion like this. So they will move like this. So they will have a lateral pressure to separate. वो ऐसे देख सकते हैं आप कि if it is a positive charge and this is also a positive charge. तो इसकी इलेक्ट्रिक लाइन ऑफ फोर्स यहाँ तो शूट 90 डिग्री घूमेगी, यहाँ भी जाएंगे, लेकिन ये आगे जाके कट नहीं सकती. इसलिए क्या होगा, ये इट विल स्टार्ट इन्फ्लुएंस लाइक दिस. ये ऐसे निकल जाएंगे. ये जो है ऐसे हो गए, नॉर्मल आएंगे लेकिन धीरे धीरे निकल जाएंगे. ये यहाँ से नॉर्मल निकलेगी, धीरे धीरे ऐसे निकल जाएगी. तो यू हैव टू ड्रॉ इलेक्ट्रिक लाइंस ऑफ फोर्स विद डिफरेंट, वो क्वेश्चन देंगे अभी. तो दैट्स व्हाई दे विल नेवर इंटरसेक्ट, दे विल हैव lateral pressure, and these electric lines of force are not continuous. ये आके घूम के यहाँ ऐसा नहीं है, and they will ultimately end somewhere else where the electric field is to vanish. So that means they are discontinuous. They are not continuous as the case is of the magnetic lines of force. Magnetic lines of force are always continuous. They are closed loops. But this is not a closed loop, it is always free end. So ultimately it is to vanish somewhere else. So there will be a break. Yes, within a certain region they are continuous. जैसे यहाँ से यहाँ तक है, they are continuous. यहाँ से यहाँ ये continuous है. But it is not continuous completely. So it is discontinuous. But in a certain space of region or certain region, it will be always a continuous. So now try to draw electric lines of force for monocharge, draw electric lines of force for number one monocharge. Monocharge means either it will be plus or negative charge. Then dipole, that means one is positive and the other is negative. Third, you can draw both are positive. So what will be the electric lines of force? Or if both are negative, then what is the nature of the electric lines of force? So you just try to draw these